Here are the notes for Lesson 3, Multiply and Divide Monomials. To begin with, one of the vocabulary words is monomial. A monomial is a number, or a variable, or a product of a number and one or more variables. Now in this box, for this vocabulary word, there's a spot to put some examples. So please think of two examples of monomials that are numbers, two examples of monomials that are variables, and two examples of monomials that are products of a number and one or more variables. I'll give you a little bit of time and then go further with the video. And here are examples that I could think of. So for monomials that are just numbers, my examples are 6 and -1/2. For monomials that are variables, my examples are x and y. And for monomials that are products, as an example, I thought of 3x, and another example that I thought of was -4ab. Okay. Now, the key concept for today's lesson has to do with powers, which we explored previously, and how you can find a product of powers. Product of powers is one of several laws of exponents. This law of exponent, or sometimes this is called an exponent rule. It's a statement of something that can be done with exponents, is called a product of powers. And here's how you find a product of powers. That is, here's how you multiply powers. To multiply powers with the same base, add their exponents. Now here's an example of what this is about. Let's say that you had the power 3 to the 2nd power, and you wanted to multiply 3 to the 4th power. Notice that these powers have the same base. The base is 3, here the base is 3. Okay? And the way that you could find the answer is to write out the meaning of these powers as we did yesterday. 3 to the 2nd power means 3 times 3. 3 to the 4th power means 3 times 3 times 3 times 3. Notice that when this is written out, that in total there are 6 3's. And so the answer is 3 to the 6th power. Now what the product of powers law is getting at is a quick way to multiply powers without having to take the time to write out the product like this and then add to see how many of the base there is. The product of powers said as long as the powers have the same base, you can add the exponents. 2 plus 4 is an exponent of 6. So that's a very fast way to simplify a product of powers. Okay? Now there's some examples. I'm going to work a few for your notes and then give you some time to work the rest of them. Number 1, simplify using the laws of exponents. The law of exponents that we're going to use to do this kind of problem is a product of powers. The multiplication indicates we're doing a product, and this is called a power, and even this is a power if you think of its exponent as being to the 1st power, meaning that there's a single 5. Okay? So what the product of powers says, to multiply powers with the same base, and these do have the same base, 5, add the exponents. And so this is going to make the base of 5, and then adding the exponents, 2, add 1, and final answer, 5 to the 3rd power. As another example of this, the product of powers law will also work with powers that have variables in them. Okay? These have the same base, c, and here the base is c. And so the product of powers law says to multiply powers with the same base, add their exponents. So I write the base and then add the exponents. 3, add 5. And that makes an answer, c to the 8th power. Okay. One more example. Number 3. Here we have a multiplication problem, so this is a product, and there are some powers in the product, x to the second power, x to the fifth power. There are some powers, but there are also numbers being multiplied that are not powers with the same base. Here we have -3. It's being multiplied by x squared, and then multiplied by 4, and then multiplied by x to the fifth power. So the -3 and the 4 are not like bases, but we can still multiply them. Okay? So here's how you would do a problem like this. Start with this number and this number. These are called coefficients. Numbers that are multiplied directly in front of variables, they are called coefficients. Multiply those coefficients together. -3 times 4. That's -12. That's just regular multiplication of positive and negative numbers. Okay. Now, for the variables, we can make use of the product of powers law. To multiply these, write the base, and add the exponents. 2 plus 5 is 7. And so the answer to this product is -12 x to the 7th power. Okay. I'm going to give you some time to work on number 4 and 5 and 6, and then the answer will be shown in the video. So here are the answers to 4, 5, and 6. In number 4, this is a product. The bases are the same, and so to get the answer, you keep that base and add the exponents. 9 to the 5th power. In problem 5, this is a product. The bases are the same. Notice that I put a 1 as the exponent on this single a, and that helped me to visualize that I needed to add 3 plus 1 to get that exponent. For problem 6, this is one of those questions where there are powers, but in front of those powers there are coefficients. And so I started this question by multiplying -2 times -8. Just normal multiplication. -2 times -8 is 16. And then for the powers, I used today's key concept about adding the exponents. 1 plus 5 makes an exponent of 6 for the m. So that key concept about the exponent law called product of powers is going to be very helpful this year. It will allow you to multiply powers together. Here is a second key concept for the lesson. This is quotient of powers, which is another one of the laws of exponents. What the quotient of powers is about dividing powers. And here's what it says. To divide powers with the same base, that's very important, subtract their exponents. Okay. Notice the connection to the previous law of exponents. Okay. Here's an example of this. 5 to the 7th power divided by 5 to the 4th power. These are powers. They have the same base. Both times the base is 5. I can write out the meaning of 5 to the 7th power as we did yesterday. That is a bunch of 5s all times together. In the denominator, 5 to the 4th power is 4 5s all times together. And then we can look at this and see why the quotient of powers works. When you have a division, anytime there's a factor in the top of the fraction that matches exactly the factor in the bottom of the fraction, they cancel away. For instance, 5 cancels this 5, because 5 divided by 5 just makes 1. This 5 cancels this 5. Again, 5 divided by 5 creates a 1. This 5 cancels this 5, and this 5 cancels this 5, creating a 1. Okay? What's left over, though? In the numerator, there's 5 times 5 times 5, and then times some 1s, but multiplying by 1 doesn't really change the value of anything. So in the numerator, we can think of it as having left over 5 times 5 times 5. In the denominator, what's left over after these canceled out is just a 1. But remember what you know about fractions. Anytime you have some number in the top of a fraction and you divide only by 1 in the denominator, it's not really necessary to even have a denominator at all. Okay? So using the canceling, we can see that we have 3 5s remaining, or using an exponent, 5 to the third power. But what the quotient of powers law is about is a fast way to find that the answer is 5 to the third power by subtracting the exponents. 7 subtract 4 makes an exponent of 3 on that base. And so we could very quickly find that result without taking the time to write this all out and write this all out and cancel like factors. Okay? Underneath here, there's some examples to practice using the quotient of powers to do division problems. I'm going to work a couple and then ask you to try some on your own. So starting with number 7, simplify using the laws of exponents. The law of the exponents that we're going to use in this case is the quotient of powers. Okay? So to do this division problem, 4 to the 8th power divided by 4 to the 2nd power, I notice that it has the same base, the base is 4, and that when they have the same base up here in the key concept, I can subtract the exponents. And so I write the base and then subtract the exponents. 8 subtract 2. That makes an answer 4 to the 6th power. Okay. Let's try number 8. This is a division problem, and using the quotient of powers law, to do a division problem where the base is the same, you write the base and subtract the exponents. That's going to make an answer of n to the 5th power. Number 9. Here is a more complicated division problem, but it's still about dividing, and the things that are being divided are called powers. So this is about dividing powers, or a quotient of powers. The word quotient refers to division. Okay? So we can do this problem using the quotient of powers law. To divide powers with the same base, subtract the exponents. Let's apply that law. Okay? I notice that here is a base of 2, and in the denominator there is a base of 2. And so when we use the quotient of powers law, you write the base, 2, and subtract the exponents. 5 subtract 2 makes an exponent of 3. But that's not all that was in this problem. There's another base of 3, and down here a base of 3. So let's work with that. Let's put a multiplication dot, and now write the base of 3 and subtract their exponents. 5 subtract 4 is an exponent of 1. One more base to go. So times. Now let's work with a portion of this problem that has to do with 5. Okay? So write the base of 5 and then subtract the exponents of the 5s. This is 5 to the 2nd power. This is 5 to the 1st power. Subtracting exponents, 2 subtract 1 makes an exponent of 1. And so this is the result for when you divide all of these powers. I got this answer by using the quotient of powers law. Okay. I'm going to ask that you work on number 10, 11, and 12 on your own, and then in a bit the answer will be shown in the video. So here are answers to 10, 11, and 12. In number 10, I wrote the base, 5, and subtracted the exponents, getting the answer 5 to the 3rd power. In problem 11, there are powers, But there are also those numbers called coefficients, which are numbers multiplied directly in front of variables. And so to begin this problem, I first divided the coefficients, just like normal math. 12 divided by 2 makes 6. And then to work with the powers, used the quotient of powers law. So this w has an exponent of 1 on it to indicate there was 1 w there. And then I'm able to subtract 5, subtract 1 to get this exponent of 4 in the answer. For problem 12, this is still a division problem, and it has many powers. And as long as you're careful and you match up the like bases, then you know what exponents to subtract. So start with the base, -2, write that base down, and then subtract exponents, 5 subtract 2, to get an exponent of 3. Then work with the base of 3. So times 3, and figure out the exponent on the 3. And then there's a base of 5. So times 5, and use subtraction of the exponents to get the exponent on the 5. And so this product is the answer to this division problem when you simplify it using the law of exponents. So that concludes this lesson about the product of powers, which is a rule or law explaining how you can find the product of powers or how you can multiply powers together. And the other idea in this lesson today was about the quotient of powers, which is a rule that explains how you can find a quotient of powers or how you can divide powers. To multiply powers, what do you do with the exponents? Okay. To divide powers, make sure you know what to do with the exponents.